Hello, students. The topic that we are discussing today is based on trigonometry. Now, this is a very important topic as far as IGCSE is concerned, right? So, the major heads under this will be Pythagoras theorem. Now, Pythagoras theorem is for right-angled triangles. Then for non-right-angled triangles, we have sine rule, cosine rule, area of triangles, applications, that means angle of elevation and angle of depression. Number 6, 3D geometry. So let's start with today's session with the introduction of Pythagoras theorem. So now, as I said, that Pythagoras theorem is applicable only to the right angle triangles. So that literally means if there is a right angle triangle and this angle is 90 degrees, so obviously the largest length is of hypotenuse and that's represented as h. The side to it is adjacent and this is opposite if this angle is theta, right? So that means according to the Pythagoras theorem, h square must be equal to o square plus a square. So that's how the Pythagoras theorem works. That means suppose if I have a right angle triangle and this angle is 90 degree and this angle is say theta, this length is 3, this length is 4, and they asked you to find the length of this hypotenuse. So that means we can apply the formula x square is equal to 3 square plus 4 square. So that means we got it as x square equals to 9 plus 16, and that's equals to 25. So the value of x has to be root under 25, which is equals to 5. So that means the hypotenuse that we got is equals to 5. So that's a very vital application on Pythagoras theorem. There are variations in these types. Then they ask you, they give you the lengths of the sides and they ask you whether the triangle is a right angle triangle or not. So in that case, you have to apply Pythagoras theorem. So that means suppose they give you the three sides of the rectangle that x equals to 13 centimeter, y equals to 14 centimeter, and z equals to 15 centimeter. So are these the sides of a right angle triangle? So that means in that case, you have to draw a right angle triangle since hypotenuse is the largest side. So you can write it as 15. This can be 13 or 14. So if this is 13, this has to be 15. So we'll have to put it up into the Pythagoras theorem that 15 square must be equal to the sum of 13 square plus 14 square. So 15 square is 225 and 13 square is 169, whereas 14 square is 196. So clearly that 225 is not equal to 169 plus 196. So that this means that it is not a right angled triangle. So this is how lots of common sums are asked on Pythagoras theorem. Now moving ahead, we have to go with the standard angles ratio, which is sine, cos, and tan. So the basic rule says if this is any right angle triangle, please look carefully. If this is a 90 degree, and if you're taking this angle as theta, the lengths are A, B, and C. So the side opposite to angle theta is written as opposite. On the same side is adjacent, and this is called hypotenuse, right? So Pythagoras theorem, as we just now learned, is applicable in all the cases. Now, if I'm writing sine theta, so the formula should be opposite by hypotenuse. If I'm writing cos theta, so the formula should be adjacent by hypotenuse. And if I'm writing tan theta, so the formula should be opposite by adjacent, right? Now, the major important part in this is, if suppose this is theta, this is 90, so this angle is bound to be 90 degree minus theta, right? So if now I want to write sine of 90 degree minus theta, So that means in that case, A becomes the opposite and O becomes the adjacent. So these two interchange their places. So that literally means if I'm writing for the sine theta in this case, so the form that I should be getting is opposite. That means it should be A by O. Rather, if I'm writing for the sine theta, so since this became A, so and this became O, so should be O by H, right? And it has been interchanged, so should be A by H in that case. Now, if I'm writing cos of 90 degree minus theta, so that will become O by H in that case because these two have interchanged their places. Now, as if you look into that, that is sine theta is equals cos theta equals to sine of 90 degree minus theta, right? Isn't it? Because both are equal to A by H. So that means sine of 90 degree minus theta must be equal to cos theta. Similarly, cos of 90 degree minus theta must be equal to sine theta. And similarly, tan of 90 degree minus theta must be equal to cot theta. So these are called complementary angles. So please do remember, a lot of sums has been asked on the application of complementary angles. Now moving ahead, we have to go by the standard angles formula. So how do we construct a standard angle table? Even if you don't remember the values, you can construct the table. So first write 0, 1, 2, 3, and 4. Divide all of them by 4. And make it under root. So now we'll start with, this is for 0 degrees, this is for 30 degrees, this is for 45 degrees, this is for 60 degrees, and this is for 90 degrees. So if I'm writing for sine, so this part becomes 0. So sine 0 degree is 0. This is 1 by 2. This is 1 by root 2. This is root 3 by 2. And this is 1. So that's the standard values for sine. If now I want to write for cos, I'll just reverse the trail. So that means 1 will come here. So that's 1, and that's root 3 by 2. That remains the same as 1 by root 2. This becomes half, and this becomes 0. So the entire series gets reversed. Now, if I want to write for tan, so that simply is the value of tan of theta is written as sine theta over cos theta. So that literally means if I have to write, so the sine theta over cos theta, so this is 0. This is 1 over root 3. This is 1. This is root 3. And this becomes infinite. That's because something divided by 0 is infinity. So this is a table which you should memorize or know, or even learn how to construct in an examination so that it becomes easier for you. Moving ahead, the types of questions asked on this is like this. They can give you a question like this, that x sine of 30 degree and cos of 60 degree is equal to tan of 30 degree, then find the value of x. So that means now you have to put the standard angle. So sine 30, as we have found in the table, is half. Cos 60 is same as writing sine 30, so that's also half. And the value of tan 30 degrees, since it's an increasing function, so it's 1 by root 3. So that means the value of x that we got is 4 by root 3, and that's the answer to the given question. So these type of questions are quite commonly asked. Now, moving ahead to the other types of questions asked here is they can give you a right angle triangle. And they can say that this is 90 degrees, so this is 30 degrees. So that automatically says that this is 60 degrees. So they can give you that suppose the triangle is A, B, and C. So they can give you the length of BC is equals to 3 centimeters. So that means this length is 3 centimeters. So you have to find the length AB and the length AC. So to get the length AB, since if we know this angle is 30 degrees, so we need to find out which ratio, sine, cos, or tan, correlates. Now this is opposite in that case, and this is adjacent. Which one correlates with reference to 30 degrees, opposite and adjacent? So the value we can know is tan of 30 degrees. So that's equals to opposite over adjacent. So that means that's equals to AB that we need to find out over 3. So the value of tan 30 degree is 1 by root 3, and that's equals to AB by 3. So the value of AB that we got is equals to root 3. So that's the value. Now, after getting root 3, we can apply Pythagoras to get AC, or we can also apply the sine rule to get, or the sine formula. So if I'm writing sine 30, so that has to be equal to root 3 over AC. And we know that the value of sine 30 is half, and that's equals to root 3 over AC. So the value of AC that we got is equals to root 3 is equals to 2 root 3. So that's the value of AC that we got. So these type of questions are quite commonly asked. Please note down the methods. Now, moving ahead to sine and cosine rule. Now, suppose if there's any triangle, this is very important, students, please pay attention. Any triangle, right? So if I'm constructing this as angle A, so side opposite to it should be marked as side A. If I'm taking this as angle B, so side opposite to it should be marked as B. And if I'm taking this angle as angle C, so side opposite to it should be marked as C. So if I'm going for the sine rule, so that means I can write it as sine A by A is equals to sine B by B. And that's equals to sine of C by C. So that's how the sine rule works. This is known as sine rule. Please note it down. Very, very important. Now, moving ahead with the types of questions asked on sine rule is these types. So that basically means if I have any triangle like this, and I say that this length is 3, this length is 4, this length is 5, and this angle, or rather I can say that this length is x, which we have to find out. And this length, this angle is 45 degrees. This angle is 60 degrees. So that means if we are applying sine rule to this, so just look at this. Opposite to 3 is 60 degrees. So that means we can write sine of 60 degrees over 3. Now, opposite to 45 is x. So that means we can write it as sine of 45 degrees over x. So now we can put the value. So that's root 3 by 2. So that's root 3 by 2 into 3. And that is equals to sine 45 degree. That means 1 by root 2x. So that means this gets cancelled. So that means basically we got it as 2 root 3 is equal to root 2x. So in that case, the value of x that we got is equals to root 6. Now, that's the length of the side that we are getting. So this is how we apply sine rule to get the length of any side or the missing side. Once two sides are known, we can easily get the third angle and get the third side as well, right? In this case, the 4 is not there. So we just have 3 and x. Now, moving ahead to other very vital part of this theorem is known as cosine rule. So cosine rule states that, suppose again, there's any triangle, necessarily not needed to be a right angle triangle. So if this is an angle A, side opposite to it is side A. If this is angle B, side opposite to it is side B. And if this is angle C, side opposite to it is side C. So we can write any square side. So if it's A square, so we write blindly the squares of the other two sides. That's B square plus C square minus 2 into B into C. And if this is A, so we'll multiply it with cos of A. So that's the formula for my cosine rule. So let's repeat this. If I'm writing B squared here, so I'll blindly write the square of the other two sides minus 2 into A into C into cos of, if this is B, so that should be B. And similarly, if I'm writing for C squared, so that has to be A squared plus B squared minus 2 into A into B, and that's into cos of C. So this is known as my cosine rule. All of you, please note it down. This is very, very important in the paper. Now, moving ahead with the application of cosine rule. Now, suppose we have any triangle. In this case, we make it easier to select a right angle triangle. So suppose if this angle is 90 degrees, right? Isn't it? So we just take up a Pythagorean identity that this is 3, this is 4, and this is 5. So suppose if I need to get the magnitude of the angle A, right? Isn't it? So we need to get the magnitude of the angle A. So we'll write the opposite side square. So that's 4 square. That must be equal to 3 squared plus 5 squared minus 2 into 3 into 5, and that's into cos of A. So we can simply solve it thus as 16 equals to 9 plus 25, that's minus 30 cos of A. So we'll first move these to this side. So that becomes 16 minus 34, and that's equals to minus 30 of cos A. So that's 16 minus 34, and that is equals to minus of 18, and that's equals to minus of 30 cos A. So minus gets cancelled from both the sides. So the value of cos A that we got is equals to 18 by 30, and that is equal to, in this case, if we cancel it by 6, so that's 3 by 5. So as we can see, if that is cos of A, so that is equals to 3 by 5. If now I need to get the magnitude of A, so we can simply write cos inverse of 3 by 5, put it into the calculator, and we get the answer into degree or radians, whichsoever is required. So this is how we use cosine rule to get any angle, any unknown side. If angle is known, we can get the unknown side also. If three sides are known, we can get unknown angle. So that's what is the application of cosine rule. Now, moving ahead is a very important part that we say as the area of any triangle. Now, suppose we have any triangle like this. Again, if this is angle A, side opposite is angle side A. If this is angle B, side opposite is B. And if that's angle C, side opposite is C. So if I have to write the area of this triangle, so please remember, so formula says half into product of the sides. So if I'm taking these two sides, which is A and B, into sine of angle between them. So between A and B, we have angle C. So that means into sine of C. Similarly, if I'm writing half, and if I take the sides B into C, that means if I'm taking these two sides, so the angle between them is A. So that means that's into sine of A. Similarly, if I take the sides C and A, so half C into A, and the angle between them is B. So the area has to be sine of B. So that's how the area of a triangle formula works. Now, moving ahead with the types of questions asked on this is this. Now, suppose what they can give you is this is the two sides. This is 3, this is 4, and the angle between them is 45 degrees. And that's the triangle ABC. So they will ask you to find the area of this triangle. So if I'm finding out the area of this triangle, so that means we'll use half into the product of the sides 3 into 4 and sine of angle between them. So that means sine of 45 degrees. So I can cancel this out. So that means it becomes 6 into sine of 45 degrees. And we know from standard angles that that's equals to 1 by root 2. So that means we can write the area as 3 root 2 square length, right? So that's how we work out for the area of any triangle. Now, there are two types of problem in this case. Now, sometimes what they can do is they can give you the area and ask you to find the unknown side. So that means if I'm writing that suppose this length is 4, this length is x, and the angle between them is 60 degrees. And I have already given you that the area is equals to say 6 square centimeters. So that means this is 4 centimeter, this is x centimeter, and the angle is 60 degrees. So again, I can apply the formula half into 4 into x, and that is equal, and that's multiplied by sine of 60 degrees, that's the angle between them, and that is equals to 6. So that means I can cancel this. So I can write 2x into sine 60, which is root 3 by 2, and that is equals to 6. So again, 2 gets cancelled. So the value of x is 6 over root 3, or we can write it as 2 root 3 centimeters. So that's the length of the side that we are looking for. So you have to apply the formula correctly. You have to look out which parts are given, which parts are not given, and then apply the formula to get the result. Now, moving ahead to the other part of trigonometry is its applications. Now, in these type, which we usually say angle of elevation and angle of depression. So if I'm measuring an angle of elevation, so that has to be measured from a plane. So that's the angle of elevation. That's theta. This is called angle of elevation. Now, please remember, if I'm measuring an angle of depression, so that has to be taken from a reference too. So that means if this is the plane and if I'm measuring, so this is called the angle of depression. So a lot of questions, typical questions has been asked on this. One of the types that we'll be discussing today is suppose there is a boat and there's a lighthouse. So boat is a distance of 10 meters from the lighthouse. So that means we'll draw the lighthouse first, and boat is at a distance of 10 meters. So the angle of elevation from the boat to the top of the lighthouse is 60 degrees, right? So then we need to find the height of the lighthouse AB, or a height of the then we have to find out the height of the lighthouse AC. So that means this distance is given to us, which is 10 meters, and the angle of elevation is 60 degrees of the top of the lighthouse. So if now we are finding out that what should be the lighthouse, so we'll first have to find out which ratio, sine, cos, and tan. Now this is, if this is 60 degrees, so this is obviously adjacent and this is opposite. So which of sine, cos, or tan correlates adjacent and opposite? So the answer is tan theta. Now, tan theta is something which is given as a generic formula of O over A. So here theta is 60 degrees. So we can write tan of 60 degrees, and O is nothing but the height of the lighthouse, which is AC, and A is given as 10. So that means the length or the height of the lighthouse AC is 10 into root 3, because the value of 10 60 degrees is root 3. So that's how we get the height of a lighthouse, which they have asked. Now, the other thing is, there are a lot of questions which has been asked based on this, and the other typical one which we'll be discussing is right now. Now, again, it says that there's a lighthouse and when the boat is at, say, 10 centimeter, or rather 10 meters from the lighthouse, so the angle of elevation is 60 degrees. Now, if boat reaches a point C, so again, the angle of elevation of it changes to, say, this is 30 degrees and this is 60 degrees, right? So if boat was initially here and that was at a distance of 10 meters, so, and if it has reached that point C, and that's the distance from where the angle of elevation of the top of the lighthouse is 60 degrees. And if I say that the length of the lighthouse is, or the height of the lighthouse is 100 meters. So what is the distance that we get is DC, right? So this is 60 degrees. So we need to get the length DC. So in that case, we can simply apply a Pythagoras theorem to get the length DC, because we can construct that this is 100 meters. Now this is 60 degrees, right? So 60 degrees means, and this is 100 meters, that's the height of the lighthouse. So we need to get this. So this is A, this is D, this is C. So again, we need to think of the ratio sine, cos, and tan, which we can apply. So again, it will be applied as tan of 60 degree is equals to opposite by adjacent. So that's 100 over DC. So we got DC as 100 over root 3. So yeah, that's how we can calculate the distances that we need to find out. Now, in this case, we have taken an arbitrary value. So the height, so that's what we got a value of DC, which is even greater than the value of DB, which was 10 meters. So that literally means that we have to adjust the value. So this was just an example that we are talking about. So if we talk about a generic thing, so that literally means if we are drawing a figure in which we have this angle as theta, and this is as x, and we have to get this y. So we can easily write that tan theta should be equal to x by y to get that value and put it into the equation. So the values that we have taken were the arbitrary values. So, but the method remains the same. Now, moving ahead to the next part of it is what we say as a combined question on sine, cosine, and area of the triangle. So we'll just try to put up few questions for the area of the triangle in a minute. So yes, we'll resume on with this type of questions. Now, if you're solving this question now, says calculate Wx, that means you have to calculate this length, which is x. Given that yz is equal to 15 meters, so that means this length is 15 meters, that's yz. Now, first of all, we need to calculate this length, which is, say, suppose if I'm taking this length as z, right? So if I'm writing tan of 20 degrees, so that has to be equals to x over z plus 50. Since I know the value of 20, so I'll get a relation between x and z. So that's the relation which I'll get between x and b. Now I'll take up the triangle WXY. So that means if in that I can write tan of 40 degrees is equals to x over z. So I straightforward got the relation between x and z. So the value of x is z into tan of 40 degrees. So I can easily place the value of z as x by tan 40 over here, and I can solve for x. So that means the value of z that I got is x over tan of 40 degrees. I can calculate this value and put up over here to get the value of x. And that will give me the height of Wx. So this is one of the typical problems that's quite commonly asked in the paper and examination. So please all of you note this down. How can we solve these type of problems? Now, moving ahead, I'll give you a minute to write this down. Then we'll place the other ones. So the other types of questions that are asked is these types. So in these types of questions, see, calculate the side or the angle marked with a letter. So here they have marked an angle x. So how can we get x from here? So see, if this is x, that's true that this is adjacent, this is opposite, and this is hypotenuse. So we need to think for a ratio like sine, cos, or tan, which is related directly with adjacent and hypotenuse because these two lengths are given. So we remember that cos of x is equals to adjacent by hypotenuse. So if I'm responding for the A part of the question, so we got cos of x as equals to adjacent over hypotenuse. So that means it's 7 by 10, or cos of x is 0.7. We can easily get x as cos inverse of 0.7, put an answer in degrees or in radians whatsoever asked for. So that's how we reply to the A part of the question. Now moving on to the B part of the question, again, we see that this is adjacent and that's opposite. So that means we again have to apply. We know opposite and adjacent. So to respond for the B part of the question, we have to apply tan of y, and that's equals to 8 over 5. So that is equals to 1.6. So that's the value of tan of y. So we can get y as tan inverse of 1.6 and write down the answers either in degrees or in radians. Now, similarly, moving on to the C part of the question, if this is 31.7 degrees and that's A. So if this is theta, so that's obviously opposite and that's hypotenuse. So opposite by hypotenuse is sine. So that means we know as sine of 31.7 must be equal to A over 7.4. So we can easily get the value of A as sine of 31.7 degrees multiplied by 7.4 and we get the answer. Now moving on to the D part of the question. So that means if I'm writing for the D part of the question, so they have asked for the side C. Now, in this case, we know that this angle is 71 degrees. So that's obviously that this is opposite and this is adjacent and this is hypotenuse. So that means something which relates with adjacent to hypotenuse. So again, we can use cos. So cos of 71 degrees is equals to adjacent by hypotenuse. So that means 11 by C. So we can easily get the value of C as 11 by cos of 71 degrees. And that will give us the answer. So a lot of these types of questions are quite commonly asked in the question paper. Please note it down. I'll give you a few minutes to write. The very important type of questions asked in board examinations where most of the students make error is like this. They have given you the value of sine x as minus half. And they told you to write an answer between 0 to 360 degree and you have to get the two values of x. So that literally means this one. So that literally means we have to get the two values of x, which is a solution of this in 0 to 360 degree. So if I write x equals to sine inverse of minus half. Now, sine inverse of minus half, so that will give you an angle which is called minus of 30 degrees. Now, if you plot that, so the minus of 30 degrees will be an anti-clockwise angle like this, or rather clockwise angle like this, which is minus of 30 degrees. But minus of 30 degrees does not lie in the domain, right? So to put an angle into the domain, now sine is negative in the fourth quadrant. We know that. So that means we have to write this angle. So that is equals to 360 degrees minus 30 degrees, and that is equals to 330 degrees. So that literally means one answer which lies in the domain for x is equals to 330 degrees, but they said two values. Now, again, if I extend this here, so that's vertically opposite angles and that's 30. So if now again, sine is positive in the first quadrant and in the second quadrant, but here the value is negative. So that means that angle should lie in the third quadrant. So this angle should also be 30. So that means if this is 180, so the other value should be 180 plus 30. So that is equals to 180 plus 30 is 210 degrees. This is a very typical question asked in trigonometry for the students. Please remember this method, how we are going for it. Just for your reference, we can say that for ASTC rule, that's ASTC. So that literally means if this is 0 degrees, this is 90, this is 180, this is 270, and it's back to 360 and the cycle goes on. So this is known as first quadrant in which all the ratios are positive. This is known as the second quadrant in which only sine is positive. Rest all are negative, and this is known as the third quadrant, which is only tan is positive and rest all are negative, and this is known as fourth quadrant where only cos is positive and rest all are negative. Since sine has got the negative value, so it should lie in third and fourth quadrant because in first and second sine is positive. So as you can see, the angles are lying in the fourth and in the third quadrant. So you need to mention this, you need to check this out very well, that you have got the correct values. And this is how we go for most of the typical problem solvings in trigonometry. Please note this down properly. Final part that we need to discuss is the graph of sine and cosine functions. So please remember that any generic sine or cosine function is written as a sine of bx. So if I talk about the amplitude of it, So that's equals to A. And if I talk about the time period, and so that's equals to time period T equals to 2 pi over B. So that means if I'm drawing any generic sine curve, so it should start from 0. That's the point on the graph, which is at 0. That's at the origin. So if it's A sine bx, so that literally means it will go up A units, go down A units, and will end at 2 pi by B. That means this height should be A, this height should be A, and will end at 2 pi by B. Similarly, if it's a cosine graph where we can write A cos bx, so the basic definitions remains the same, that the amplitude is A and the time period is 2 pi by B. The only difference from the cosine graph is that at origin, it will always start from A in this case. It starts from A, go down at A, and climbs again at A. So that literally means that this height is A, goes down by A, and it is at A here and ending at 0.2 pi by B. Right. So a lot of questions has been asked on this particular thing also. I'll ask you, all of you, to note this down. Very, very important part. Now, the types of questions asked on this is pretty simple. So they can tell you that you have a wave as number one, y is equal to 5 sine of 2x. Find its time period. And in the other case, they can give you, you have a wave as 6 cos of bx, and its time period is equals to 3 pi. So find the value of b. So now, in the first case, so we'll first have to write the value of a. So if I'm writing down the answer, so the a equals to 5 and b equals to 2. So we know that the formula for the time period is 2 pi by b. So that means it should be equal to 2 pi by 2. And that should be equal to pi. So that's the answer for the time period of any wave. Now, if I'm responding to the second part of the question, so again, we write the value of A, which is 6, and we write the value of B, which is B itself. Now, we know that the formula for time period is 2 pi by B. Here, they have given us the time period as 3 pi. So that means 3 pi must be equal to 2 pi over B. So we can easily get the value of B as 2 pi over 3 pi, so pi gets cancelled. So the value of b is equals to 2 by 3. So both of them are quite commonly asked in the exam pattern questions. So all of you, please go through these. If any doubts, do reach out to us, and we can help you out from the exam point of view. All the very best for your exams. Any queries, any questions, do reach out to us. Thank you, students.